Hi everyone. So we've talked about a couple of different ways to solve quadratic equations, and the next one is solving quadratics by completing the square. This way definitely tends to be one of the hardest ways, but it's a good thing to learn. You'll use it in um, math classes to come for different things. It's not even just solving quadratic. So it's a good process to understand. All of these steps are really easy. There's just a lot of steps to go through. So the easiest way for me to show you is just to start by going through an example. The first example is x squared minus 16x plus 39 is equal to 0. And in order to solve quadratics by completing the square, what we want to do is get the x chunks on one side and the stuff without the x's on the other side. So what that means is I have to move the 39. And the way I'm going to move the 39 is by subtracting it from each side. So when I subtract 39 from the left side, it just cancels out, and I'm left with x squared minus 16x. And then on the right side, I have 0 minus 39, which gives me a negative 39. Okay, now we're set up to complete the square. So once we have it set up this way, we're going to use the completing the square formula, which is b over 2 squared, where b is the number with just one x, or it's considered what's called our linear term, but it's the number with one x. And so in this case, our b is negative 16. We don't put the x with it, it's just the number. So negative 16, which means I'm going to write this as negative 16 over 2 squared. And I can plug that into a calculator. When I plug that into a calculator, I end up with 64. Okay, so that 64, what we're going to do with it is we're going to add it to both sides of the equation. So I'm not going to change anything about the equation. I'm just going to add it to both sides. And the reason why I add it to both sides is because what I do to one side, I have to do to the other side, right? So we have plus 64 on both sides. And the reason why we do that is because now the left side of our equation looks like something we can factor, but it's what we call a perfect square. So a perfect square is definitely factorable, but I'm going to show you, and I'll show you how to factor it, but I'm also going to show you, because it's a perfect square, there's a little bit of a quicker version to do it as well. So we're going to use the box method to factor this just for this one. So we'd have the x squared over here and the 64 over here. We want to find two numbers that multiply to be 64 and add to be negative 16. Because it's something called a perfect square, that tells me that it has to be the same number. And so 64, I can say, is 8 times 8. In order for it to add to be negative 16, though, both of those 8's have to be negative. So I can write a negative 8x in one box, a negative 8x in the other box. Then we can factor it. The bottom two boxes have a negative 8 in common. The top two boxes have an x in common. The left two boxes have an x in common, and then the right two boxes have a negative 8 in common. And so my factors are x minus 8 and x minus 8. And that's just how I can rewrite the left side of this equation. And now the right side of the equation is negative 39 plus 64, which I can plug into a calculator, and that gives me 25. Okay, so now we have it, and it's a little bit prettier, but we haven't solved anything yet. We're almost there, though. So when I have something written out twice, this x minus 8 written out twice, I can actually write it out as x minus 8 squared because it happens twice. And that'll be really helpful because now, if you remember from our video a couple videos ago how to solve with square roots, to get rid of a square, we square root to each side. So I'm going to square root the x minus 8 squared, and then square root the 25, but remember you have to put that plus or minus there, because whenever you square root a number, you put the plus or minus there. The square and the square root cancel each other out on the left side, and we're just left with x minus 8. And then on the right side, we have plus minus the square root of 25. The square root of 25 is 5, so it'd be plus minus 5. So now I can write my two equations as x minus 8 equals 5, and x minus 8 equals negative 5, and then solve both of those. So we add 8 to each side for this one on the left, and we'd end up with x is equal to 13. So that's one of my solutions. And then on the right equation, we add 8 to each side, and we end up with x is equal to 3. So these are my two solutions, either x is equal to 13 or x is equal to 3. So like I said, it's a long process, takes a lot of steps, but all of those steps are pretty easy. Okay, let's go through another example. The second example is x squared minus 8x minus 10 is equal to 0. So once again, we want to get it into that format that we can complete the square in. To do that, we need to move the 10 so that the x's are on one side and the stuff without the x's are on the other side. To move the 10, I'm going to add 10 to each side. So the 10's cancel out over here on the left side. I'm left with x squared minus 8x. And then that's equal to 0 plus 10, which is 10. Now that we have it in this form, we're going to use the completing the square formula, which is b over 2 squared. And our b is the number with just one x, so in this case it's negative 8. We're going to say negative 8 over 2 squared. And then we plug it into a calculator. Negative 8 over 2 squared gives me a 16. So that 16 I'm going to add to both sides. So we have x squared minus 8x plus 16 equals 10 plus 16. Once again, you have to add it to both sides to keep that equality. And now that we've added it to both sides, this left side turns into what we call a perfect square. Now, I told you could potentially use the box method for this, and you definitely can, but I want to show you the quicker version. Because we know it's a perfect square, what we can do is instead of drawing out that entire box and finding the factors and everything like that, we can actually write it out like this and say, take this middle number and just divide it by 2. So let me scratch that out for a second. Negative 8 divided by 2 gives me a negative 4. So what that tells me is my factors will be x minus 4 and x minus 4. You could double check that with the box method, but I can tell you it's right. So that's my factored form. And then on the right hand side we have 10 plus 16, which gives me 26. And now when we have something written out twice, as in the x minus 4s, we can write it out as x minus 4 squared equals 26. All right, now we're going to use the square root method to get rid of the squares. So we're going to square root the x minus 4 squared and square root the 26. But when I square root a number, I always have to put the plus minus. The square and the square root cancel each other out on the left side, which means I'm just left with x minus 4. And then on the right side, we have plus minus the square root of 26. The square root of 26 is not perfect, so we're going to write the decimal version of it, which is 5.1. So it's plus or minus 5.1. So now because of that plus minus, I can write it out in two different forms. I can say x minus 4 is equal to positive 5.1, and x minus 4 is equal to negative 5.1. And then we're going to solve both of those. For the left equation, we would add 4 to each side. The 4's cancel out over here. We're left with x. And then on the right side, we have 9.1, because 5.1 plus 4 is 9.1. There's one of my answers. And then for my other answer, I'm going to add 4 to each side again. The 4's cancel out over here. We're left with x is equal to negative 5.1 plus 4 is a negative 1.1. And here are my two solutions. All right. Let's do another example. So for the third example, it's actually already set up really well for us because we have the x's on one side and then the stuff without the x's on the other side, which means we can automatically start with our completing the square formula, b over 2 squared. Our b in this case is the number with just one x, which means it's negative 8. So we say negative 8 over 2 squared, which when I plug that into a calculator gives me 16. I'm going to add 16 to each side. And then the left-hand side turns into a perfect square. This is the same perfect square as the last example. So if you remember, we took that middle number, which is negative 8, and divided it by 2, which gave me negative 4, which means my factors are x minus 4 and x minus 4. And then on the right-hand side, we have negative 4 plus 16, which gives me 12. We know that when we write out x minus 4 twice, we can write it as x minus 4 squared is equal to 12. And then we want to get rid of the squared, we're going to square root each side. So we do the square root of x minus 4 squared is equal to plus or minus, because you always do plus or minus the square root of 12. The square and the square root cancel each other out. On the left side, we're just left with x minus 4. And then on the right side, square root of 12 is not a perfect square, so we can plug it into a calculator, and it is 3.5 when we round it to the first decimal. So it's plus or minus 3.5. Now we can write it as two separate equations, as x minus 4 is equal to positive 3.5, and x minus 4 is equal to negative 3.5. And then solve both of those. To solve the left one, we add 4 to each side. The 4's cancel out over here. We're left with x is equal to 3.5 plus 4, which is 7.5. And then on the right equation, we still add 4 to each side. 4's cancel out over here. We get x is equal to negative 3.5 plus 4 is 0.5. So here are my two solutions for this one. All right, let's go through one more example of how to use the completing the square formula, or how to complete the square to solve. And the last example is x squared is equal to negative 2x plus 24. The first thing we want to do is get it into that form where the x's are on one side and then the stuff without the x's are on the other. To do that, we're going to add 2x to each side. So we get x squared plus 2x is equal to 24. That x squared and the 2x are not like terms, so you can't add them together. They just sit right next to each other. So now it's in the perfect form for our completing the square formula, which is b over 2 squared. The b is the number in front of just the 1x, so it would be, in this case, 2 over 2 squared. When we plug that into a calculator, we end up with 1. So that's the number I'm going to add to both sides to keep the equality. And then this is our perfect square. We can do the box method, but we can also take that middle number and divide it by 2. You always divide it by 2, which gives us 1. And then that tells me that I'm going to have x plus 1 as my factors. And that's equal to 24 plus 1, which is 25. Okay, x plus 1 can be written out as x plus 1 squared because it happens twice. And then to get rid of the squared, we square root each side. So the square root of x plus 1 squared is equal to plus or minus the square root of 25. The square and the square root cancel each other out. On the left side, we're just left with x plus 1. And then on the right side, we would have plus minus the square root of 25 is 5. So now I can write it out as two separate equations. X plus 1 is equal to 5, and x plus 1 is equal to negative 5. I can subtract 1 from each side over here. The 1's cancel out, and I'm left with x is equal to 5 minus 1, which is 4. And then I still subtract 1 over here to solve the second equation. The 1's cancel out. I get x is equal to negative 5 minus 1, which is negative 6. So here are my two solutions there. All right, and this is how we solve quadratics using the completing the square formula.